Assalamualaikum and hi everyone. This week we are going to study chapter 10, Differentiation part 1. The subtopics of this chapter are derivative of a function, rules of differentiation, and the last one is implicit differentiations. The objective of this chapter is to define the derivative of a function at a point such as f prime x equal to the limit of x approaches 0 for fx plus delta x minus fx over delta x, and then interpret the derivative of a function geometrically, and then to define the derivative of a function at any point such as f prime a equal to limit x approaches a fx minus fa over x minus a. Okay, now we look at the derivative of a function. What is actually the derivative? Basically, the derivative of a function fx represents its rate of change and is denoted by either f prime x or dy over dx or df over dx, okay, such as f prime x or dy over dx or df over dx. Okay, let's first look at the graph here. Suppose that we wish to find the gradient. Okay, the gradient. Okay, we have a point P and Q for the curve. Okay, curve here. Y equal to fx at a point pxy. Okay, x and y. Okay, which is y is equal to fx, and then on the curve, okay, P point P, the gradient of P to Q, okay, P Q, which is equal to Q n over P n, okay, Q n over P n, which is here the delta x here represents a change in the value of x, okay, which is we have fx here, and then the change from fx plus delta x, okay, from here to here, the point, and then minus fx over x, okay, x, this one x plus delta x minus x, okay, the change of the delta x, okay, delta x, what is it? The delta x just now represent a change in the value of x, so here x, and then this one x plus delta x, okay. If we move q, okay, q nearer to P, okay, we move, for example, at the point Q1, 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 Q2, Q3, and so on. The gradient of the P, Q1, okay, P, Q2, and so on will give better approximation for the gradient of the tangent line at P. Thus, we can say the gradient of the curve y equal to fx at the point pxy is given by the limit of the delta x. Okay, just now delta x is represent the change in the value of x to approach 0, which is fx plus delta x. Okay, this one minus fx. And then just now we can see that x plus delta x minus x, so we can get only delta x. So you need to memorize this formula, okay. Okay, next, if point P equal to xy and Q is x plus delta x and y plus delta y, the gradient dy over dx is limit from delta x approaches 0, y plus delta y minus y, and then x plus delta x minus x. Okay, can cancel out, so we can get limit of delta x approaches 0, delta y over delta x. Okay, so we can say that the dy over dx is the gradient of the function. Derived function is the derivative of y with respect to x. The process of finding the derivative of a function we call as differentiation. Okay, the derivative is the instantaneous rate of change of a function with respect to one of its variable. This is equivalent to finding the slope of the tangent line to the function at a point A. Okay, sometimes we can write dy over dx, f prime x, or y prime. Basically, the application of the differentiation is sometimes the connection with velocity. One of the example of derivative we can say that velocity, which is the rate of change of distance with respect to time. So if ft represent the distance, okay, the distance for the represent the distance travel at time t, then the f prime t is the velocity at the time t. Okay, while the second derivative of the function represent its acceleration. Okay, that is application of the differentiation. Okay, just now you need to memorize the formula, the first principle of derivative. Okay, dy over dx is equal to the limits of delta x approaches 0, delta y over delta x. Okay, just now we know that the delta y, okay, represent this one, and then the delta x represent this one. Okay, from the graph just now. Okay, for the example, find the first principles, the derivative of y with respect to x, which is y equal to x squared. Okay, this is the formula just now you need to memorize. So since the function y equal to x squared, okay, this one x squared. So x squared, you need to add the value of delta x. So x plus delta x squared, okay, minus fx. So this is equivalent to fx minus x squared over delta x. And then you need to expand this one. So we can get 2x delta x plus delta x squared. This one we need to over delta x. So this one can we can cancel. So we can get 2x plus delta x. So we substitute the value, okay, of delta x approaches 0. Substitute 0 here. So we get to 2x. We proceed to the next example. Find from the first principle. Okay, first principle, just now the formula like this. Okay, we need to use the formula, the derivative of a y with respect to x if we have a, b, c, d. Okay, we look at the example 1, x squared plus 1. So by using this formula, since the function is x squared, so we substitute, we need to add the value of delta x, and then plus 1 minus the function of fx. Okay, so you expand and then solve the formula, the equation. We get this one, then we can get this one, we can cancel. So we get delta x. Okay, solve the formula, and then substitute the value of delta x into this. Okay, so we get to 2x. Next, function fx equal to set x plus 1. Okay, by using the formula, okay, this one fx x plus delta x plus 1 minus the function fx. Okay, since this is a conjugate, so we need to multiply the opposite of sign. So this is minus, so plus. Okay, solve this one, conjugate, and we can solve this one, right? So we get like this, and then we need to substitute the delta x here 0, so we can get the final answer. The same thing for c. Okay, 4 over x squared by using the formula, and then which is the function fx must be added with delta x. So 4 over x plus delta x squared minus the function fx. So we need to solve this one. We can get like this, expand, and then expand. So this one we can factorize the value of delta x, and then the remaining, the delta x, we can substitute with 0. So we can get negative 8 over x cubed. And d 1 over 2x plus 3, since we need to add the function fx with delta x. Okay, we get this one minus the function fx. Okay, we need to solve this one. We like this, and then solve, so we can cancel out, can get this one and factorize, simplify the function. We can get the final answer. The derivative of a function at any point x equal to a, let a be a number in the domain of a function f if the limit x approaches a, just now approaches this one, okay, this one, right? Then we have a point a like this, and this we call this limit the derivative of f at a, and write it as f prime a. F prime a equal to limit x approaches a, fx minus fa over x minus a, which is the derivative of a is the gradient of the tangent line to the graph of f at a, fa, which is the x and y. Find f prime a for the given value of a until c. Okay, we have the function at a given point, so you need to substitute the value of 1. Okay, after that substitute the value of fx into this one minus, which is a equal to 1, so you need to substitute 1 into x. Okay, you get this one, right? After that you solve this one like this. Okay, you solve, so we can cancel out this one, and then since x approaches 1, so you need to substitute the value of 1 into x. Okay, so we can get the value equal to 3. Same goes to b, which is a equal to 3 by using the formula. Okay, this formula. For limit x approaches 3, fx minus f3 over x minus 3, since we have this one as fx, and then f3, we substitute the value of 3 into this one, so we get 3 plus 1 is 4. Okay, since this is the third, need to multiply with its conjugate. Okay, you solve this one. Alright, so this one solve x minus 3, so we can cancel out, so substitute the value of x equal to 3 into this function, and then we can get 1 over 4 as the final answer. And then last one, C. Okay, we have a function at the point A equal to 8. So we substitute into the formula. We can solve this one. Okay, 1 over 9. So equal to 1 over set 9. So 1 over 3. We solve this one of the its conjugate. Can get this. So to get to cancel out this one, so we need to multiply with negative. Okay, so we get negative cancel out. So we get substitute the value of x in equal to 8 into this function. Then we can get negative 1 over 54. Okay, now we proceed to rules of differentiation. The objective of this subtopic is to find the derivative of function by using the rules of differentiation. The derivative of a constant function if f(x) equal to k, where k is any constant, then f prime x equal to 0. So we differentiate any constant, we can get 0. For example, this one, okay, 8, 0.73. Set 3 is a constant, so we differentiate the constant rule, we get 0. The derivative of a function of the form x power of n, which is if n is a real number, the derivative of fx equal to x power of n is f prime x equal to n x power of n minus 1. Okay, this one x power of n. So bring down, so n x, then this one you need to minus 1. Okay, if fx equal to x power of 4, and then its derivative is 4x cubed. The same thing for b, x power of 3 over 2. You need to differentiate, bring down, okay, 3 over 2x, and then 3 over 2 minus 1 equal to 1 over 2. Okay, c, fx is equal to 1 over x squared. Okay, so since it is over x squared, so it is x power of negative 2. So negative 2x, negative power of negative 2 minus 1. So we get this. Okay, since negative 3 here power, so we get negative 2 over x cubed. Now the derivative of a function of the form k x power of n. If k and n are real numbers, the derivative of fx equal to k x power of n is like this, f prime x equal to, okay, we bring down the n, okay, kn x n minus 1. So for example, fx 3x power of 4, so we get the f prime x equal to 3 times 4 x cubed. So 3 times 4 is 12x cubed. Okay, b, differentiate 3x power of negative 5. So bring down here 3 times negative 5. So negative 5 minus 1. So we get negative 6. Negative 15 x power of negative 6. Continue. Cmx equal to 12 over set x. So since set x is equal to x power of 1 over 2, so since it's below the denominator, power of negative 1 over 2, so bring down here, and then negative 1 over 2 minus 1, so we can get like this. Okay, d, same thing, the set 2x is equivalent to set 2 x power of 1 over 2. So bring down the value of 1/2 here, and then half minus 1. So we get like this. Okay. The derivative of a sum or difference. If fx and gx are differentiable functions, the derivative of hx equal to fx plus minus gx, like this. H prime x equal to f prime x plus minus g prime x. For example, 6x squared plus 3x. So differentiate this one, bring down here, so 6 times 2, and then power of 2 minus 1, so we get x power of 1, and then this one 3x, okay, 3x power of 1. Okay, bring down 1 times 3, and then x 1 minus 1 equal to 0. So any function power of 0 equal to 1. So 3 times 1 we get 3. 6 times 2, 12, 12x. B, 7x cubed plus x power of 1 over 3 minus 1 over set x. Okay, bring down here, so 7x, 7 times 3, 3 minus 1, so we get x squared. And then bring down here 1 over 3. So 1 over 3 minus 1, so we get negative 2 over 3. Minus, since the 1 over set x is equivalent to x power of negative 1 over 2. So negative 1 over 2, x power of negative 1 over 2 minus 1. So we get negative 3 over 2. So 7 times 3, 21. Okay, solve this one, minus positive. Okay, next, x squared plus 5 power of 2. We need to expand and then solve this one for x cubed. Then 10x squared equal to 20x. The derivative of a constant equal to 0. The differentiation of a function should be with respect to the independent variable. For example, y equal to fx, then dy over dx is equal to f prime x. Second one, y equal to ht, then dy over dt equal to h prime t. The derivative of a product, okay, if ux and vx are differentiable, differentiable functions, the derivative of fx equal to ux times vx, such as f prime x equal to uv prime plus vu prime. Okay, the product rules. We need to memorize uv prime plus vu prime. Okay, for example, this one, okay, the product rules. We have two functions here, and then you need to memorize u v prime plus vu prime. So u, which is u? This is u and v. Okay, u is x squared plus 2x. V prime means the derivative of v. V prime equal to 3 times 2. Okay, x power of 3 minus 1. So we get 6x power of 2. Plus v. V is this one, 2x cubed minus 5. And then u prime. This is u. U prime is 2x. Okay, 2 power minus 1. And then plus 2. So we get this one. Then you need to expand so we can get the final answer. Okay, next example. This one by using the product rule. This is u, this is v. So u v prime plus v u prime. Okay, we get this final answer. The derivative of a quotient, okay, if ux and vx are differentiable functions and vx must be not equal to 0, the derivative of this one, okay, like this, the formula. Just now for the product rule, u v prime plus vu prime, but the for quotient rule, you need to memorize this one, vu prime minus u v prime over v square. Okay, this one, the numerator is u, the denominator is v. So v u prime. U prime means the derivative of u minus u v prime. Okay, v prime, the derivative of v. So we can get 2 minus 3x, differentiate, okay, derivative, differentiate this one. So we get 4x minus 4 minus, this is the u, then differentiate v. So we get negative 3. This is v square over v square. When you solve that one, we can get this one. B, by using the quotient rule. Okay, first of all, you need to expand to be like this. Then this is u, this is v. Then the formula is v u prime minus u v prime over v square. V is the denominator, u is numerator, and then u prime means you need to differentiate u. Okay, and then you get this one. The same thing goes to this one. So u v prime, so you need to differentiate 5x minus 4, so you get 5. And then we can get this one. And then you solve this one, we can get the final answer. Okay, C, we need to expand to get in form of that like this. Okay, which is, this is u, this is v. The formula v u prime minus u v prime over v square. So we get this one, and then the final answer. Okay, now the next rules of differentiation by using the chain rule, the power rule, and to find the higher order derivative. For the chain rule, if y equal to fu is a differentiable function of u and u equal to gx is a differentiable function of x, then y equal to fgx is a differentiable function of x. Thus, we can say dy over dx equal to, okay, you need to memorize this one, dy over dx equal to dy over du times du over dx. So if we cancel out this one, okay, so we can get back dy over dx. Or equivalently, if you use fgx, so the derivative of the fgx equal to f prime gx times g prime x, okay, to equivalent to this one. Okay, so we can get fgx. Sorry. Okay, for example, find the dy over dx if y equal to u cube minus 3u square plus 1 and u equal to x square plus 2. Since dy over du equal to, okay, you need to differentiate y equal to dy over du. Differentiate u cube is 3u square. Differentiate 3u square equal to 6u. Differentiate 1 equal to 0. And then differentiate this function u equal to x square plus 2. So differentiate u equivalent to du over dx. And then differentiate x square, we get 2x. Differentiate the 2 equal to 0. By using the chain rule, just now you need to memorize the formula dy over dx equal to dy over du times du over dx. Okay, so we have dy over du and then du over dx. Then you can get here u equal to x square plus 2. We substitute. Okay, substitute. So now we can get in terms of x. And then you solve, we can get 6x cubed times x squared plus 2 as the final answer. Okay, now differentiate with respect to x by using the chain rule for a, b, c, d. Okay, just now we have y equal to x plus 4 cube. Y equal to x plus 4 cube. Let's say, okay, u equal to x plus 4. Okay, dy over du equal to 3u square. Okay, this one y. Okay, dy over du equal to, since this one is u cube, okay, we let u equal to x plus 4, so u cube, so since 3u square. And then du over dx equal to 1. Differentiate this one. Okay, differentiate u equal to x plus 4, we can get equal to 1. Differentiate x. So by using the chain rule, we substitute and we get, since u square is equal to this one, so we substitute, we can get 3x times x plus 4 square. B, y equal to 1 over 4x plus 9. 1 over 4x plus 9. Okay, dy over du, since we let u equal to 4x plus 9, okay, this one, so y equal to 1 over u. Okay, 1 over u means u power of negative 1. So dy over du terhadap u, okay, with respect to u, so negative 1 u, negative 1 minus 1, so negative 1 u power of negative 2. Negative 1 u power of negative 2 equivalent to negative 1 over u square. And then for this u equal to 4x plus 9. So differentiate this one, we can get du over dx equal to 4. So by using the chain rule, okay, you substitute, you can get this one. Okay, since u equivalent to this one, we substitute. Okay. Next, we move to C. Okay, C just now, y equal to 7x minus 2. Okay, so we let u equal to 7x minus 2, and then y equal to u. Alright, substitute. So dy over du, we can get 1 over 2 u. Okay, this one differentiate, so we get 7 by using the chain rule. And then since u here, substitute, so we get the final answer. The general power. In general, any function of the form y equal to fx power of n can be differentiated using the chain rule, and this process we call as a general power rule. For example, let u equal to fx, then y equal to u power of n. So dy over du, this one, and u at power of n minus 1, then du over dx, okay, with respect to x, we get f prime x by using the chain rule. Dy over dx equal to dy over du times du over dx. Okay, we get this one, so we can get this answer. Okay, for example, find the derivative of a and b. Fx equal to x power of 5. Okay, so you let u equal to x power of 5 plus 1, and so we get fu equal to u cube. So this is fx, so x. So if fu u cube, and then using the power rule, f prime u means the derivative of this one, we need to differentiate, so 3u square. Then du over dx for this, we get 5x power of 4 by using the chain rule. Okay, we get the final answer 15x power of 4 times x plus x power of 5 plus 1 square. Okay, B, y equal to 2x power of 4 minus 9x plus 6 power of 4. So we let u equal to this one, and then we get y equal to u power of 4. Okay, dy over du 4u cube, and then du over dx. Okay, the function u with respect to x, so we get 8x cube minus 9. By using the chain rule, okay, dy over du times du over dx, so we get this one. Okay, differentiate the gx equal to sed x over sed x over 1 minus x. So we get here, we let u equal to this one, and then gu equal to u power of 1 over 2. Okay, sed is equal to power of 1 over 2. So dg over du times du over dx, this one dg over du. Okay, differentiate this one, and then times du over dx. So since this is the quotient rule, you need to use the quotient rule. This is fraction here. So this is u, this is v. By using the formula v u prime minus u v prime over v square. Okay, this is the numerator u, denominator is v. Thus we can solve this one, right, from this one. Okay, we multiply, but since it is power of 1 over 2, this is power of 1 minus x power of negative 2. Okay, 1 over 2 plus negative 2 is equal to negative 3 over 2. So since negative 3 over 2, so it is the denominator. So we can get this one, the final answer. So you need to do this exercise by yourself. Okay, try to solve this one. We let u equal to x plus sed x squared plus 3. Then we let's say that y equal to u squared, because this we let as u. Okay, dy over du, this one, and then du over dx, this one. So by using the chain rule, okay, we can get the answer. For the higher order derivative, the first derivative, okay, y prime f prime dy over dx or d over dx of fx. Then second derivative, y double prime f double prime, differentiate of dy over dx, okay, equivalent to d square y over dx square or d square over dx square fx. The third derivative, okay, and so on. The nth derivative, power of n, power of n, power of n here. Okay, we look at the example y here. Okay, here we look at the example to find dy over dx and then its second derivative for the quotient function. By using the quotient rule, this is u, this is v. So v u prime minus u v prime over v square. So we solve this one, we can get this one, and then we need to find the second derivative. So this is u, this is v. Okay, for this one, the second derivative. So v u prime, okay, this one is v, the denominator, and u is numerator. Okay, the same thing here, v u prime, minus u v prime over v square. So differentiate negative 1 minus x square is negative 2x. Differentiate x square equal to 2x. So solve this one. We can get like this and they expand. Okay, we can factorize. Get the final answer. Okay, another exercise. If y equal to this one, okay, you need to try to solve by yourself, and then you can see the final answer. Okay, either you can get the final answer or not. Okay, it's better for you to do it by yourself, and then you can check your answer. You show that dy over dx equal to this one. Then last one is to find the second derivative. Okay, dy over dx, just like this. This is u, this is v. Okay, v u prime minus u v prime. Differentiate u prime, so we get 2x. Differentiate x minus 1, so we get 1. So we solve, okay, we can get the final answer. And then you need the second derivative. So now, by using this one, dy over dx, so this is u, this is v. So v u prime minus u v prime over v square. We differentiate x square minus 2x, so we get 2x minus 2. Differentiate v prime, differentiate x equal to 1. Then we can get v square, can dissolve, we get the final answer. Okay.